Good day everyone! Welcome to Sir Fox Learning Channel. For today's video, pag-aaralan po natin, kailan po ba natin masasabi na yung isang bagay nasa equilibrium state? At paano natin madedetermine yung center of gravity ng isang bagay at yung center of mass ng isang bagay? Kung gusto mong malaman ang mga konseptong ito, panoorin mo ang video ito. Happy learning everyone! Okay, ang pag-aaralan niya natin ngayon sa video ito ay patungkol po sa impulse and momentum, equilibrium, center of gravity, and center of mass. Our learning target here under week 7 for General Physics 1 is to differentiate center of mass and geometric center, relate the motion of the center of mass and system to the momentum and net external force acting on a system. And that's our learning target for this video lesson. Momentum is defined as the product of moving body's mass and its velocity. Basically defined as the product of moving body's mass and its velocity. Mathematically expressed as P is equals to mv, where P is the momentum, m is mass, and v is velocity. For instance, Rich Gozaj set a fastball record by hurling a 0.14 kilogram baseball at a speed of 46.3 meters per second. What is the magnitude of the baseball momentum? So in solving problem, we always determine the given. Our given here is 0.14 kilograms as the mass, and the velocity of the ball is 46.3 meters. By substitution on our mathematical expression for momentum, mass times velocity, our mass is 0.14 kilograms times 46.3 meters per second. Your momentum of the baseball is 6.5 kilograms meters per second. However, impulse is the change in momentum defined as the product of force and time. From the second law of motion, force is equals to mass times acceleration, and acceleration here is equal to the final velocity minus its initial velocity over time. By substitution for force is equals to mass times acceleration, you substitute the value of A, therefore you have mass times the quantity of final velocity minus initial velocity all over time. And therefore, your impulse expression is mass times by multiplying both sides by t. You will get F times t, or impulse is equal to mass times velocity or final velocity minus mass times the initial velocity. If you are going to determine the force acting on that certain object or body, you will have mass times the final velocity minus the initial velocity all over time. For instance, you have a 2 kilogram ball which is kicked from rest, giving a velocity of 10 meters per second. Find the impulse for letter A. Letter B, if the ball and foot were in contact for 0.25 seconds, how much force exerted by the foot to the ball? For us to solve the problem, the first thing you should do is to determine the given. Your given here is mass 2 kilograms, initial velocity which is at rest equal to 0, final velocity 10 meters per second, and your time for letter B is 0.25 seconds. For letter A, by substitution with the formula of impulse, force times time is equal to 2 kilograms times the final velocity minus initial velocity, 0 meters per second. Meters per second po yan. And you will get 20 kilograms meters per second. If you are going to determine the force acting on the football, exerted by the foot to the ball, you have MVF, or mass times final velocity minus mass times initial velocity over time. By substitution, you will get 80 newtons. Okay? Did you get it? Now, when we speak about equilibrium, basically, in mechanics, one area in mechanics is static. Static is the study of forces acting on a bodies at rest. An object at rest, or object moving with constant speed, is said to be in equilibrium. When we say equilibrium, it is the condition in which two or more forces acting on an object which produces no acceleration because they balance, or they balance each other. Since we're talking about mechanics, when we speak about mechanical equilibrium, it refers to a condition which the vector sum of the forces acting on a body is equal to 0. So meaning the body is at rest. Therefore, or either the forces are opposing each other, and therefore the acceleration is equal to 0. The vector sum of all external forces is equal to 0. These are the conditions for mechanical equilibrium. And the second condition is the sum of the moments of all external forces about any line is equal to 0. So we have classification of mechanical equilibrium. The static equilibrium, which refers to the condition in which all forces acting on the body are balanced, causing the body to remain motionless. However, dynamic equilibrium, these are mechanical condition in which a net force acting on a body produces a motion with the constant velocity. Since we are talking about mechanical static equilibrium, we will focus on this. Objects at rest and the acceleration is equal to 0. Ito yung ating main target for this video lesson. Rigid body, when we say rigid body, these are bodies which refers to an object extended in space which does not change its size or shape when subjected to force. So this is a rigid body. Those objects that does not change its size or shape when subjected to force. It is also a mechanical equilibrium when the sum of all forces on all particles of the system is equal to 0. And the sum of all torques on all particles of the system is equal to 0. For us to state its equilibrium, the stability, when we say equilibrium, the stability, let us determine the different types of equilibrium. We have here the stable equilibrium, the unstable equilibrium, and the neutral equilibrium. When we say stable equilibrium, it is a condition where a body returns to its original position after being slightly disturbed. For instance, an object is in stable equilibrium if its center of gravity is at the lowest position. So, for instance, if a ball is displaced with a it will return to its original position, and therefore it the equilibrium of the ball is at stable state. However, when we say unstable equilibrium, it is achieved by a small displacement or rotation. The equilibrium is unstable if the center of gravity is at its highest possible position. For example, if the ball is displaced, it will accelerate when from the equilibrium point. So take a look at the figures illustrated. However, when we say neutral equilibrium, it occurs when the center of gravity is neither lowered nor raised when the object is slightly disturbed. For instance, if the ball is displaced, like what are you, or like what is illustrated here, displaced, it will stay in its new location. Okay? And the stability of an object probably depends on the following factors. One is the area and of the base, the weight of the object, and the line of action of the center of gravity falls with the base of the object. So these are the different types of equilibrium, or the different state of equilibrium: stable, unstable, and neutral. Now, for us to determine the center of gravity, it is the point of an object wherein all gravitational torques cancel. And the center of gravity usually coincides with the center of mass, which is the average position of all particles of the object. And the location of center of gravity of objects varies. For instance, for regular shaped object, the center of gravity are found at their geometric centers. However, for the irregularly shaped object, the center of gravity are found near the thicker end. Take note for this. Regularly shaped object, the center are found, or the center of gravity are found at the geometric centers. However, irregularly shaped object, the center of gravity are found near the thicker part of the object. Example here is the baseball bat, which is the center of gravity is near at the thicker part. All right. For instance, I have here two illustrations where we could determine the center of gravity. The first illustration is the hammer, and you will notice the center of gravity is of the hammer is at this position near the hammer head. However, on the second illustration, a bus rights itself, moving at an elevated road. The center of gravity moves or looks like this. And however, in another picture illustration, the bus is highly elevated, and therefore the center of gravity changes. Okay? So for us to determine, usually to determine the center of gravity of an object, we usually use the Plumb bob. Now, if we are asked to calculate the center of gravity, we have here the mathematical expression: center of gravity is equals to the weight of an object, initial weight of an object, or W sub 1, and the distance of its weight, plus weight sub 2 and D sub 2, or displacement sub 2, all over the total weight of weight sub 1 and weight sub 2. Okay? If we assume, let us assume that this hammer, the head is 1 kilogram, however, the handle is 0.5 kilograms, and the length of the head, the metal part, usually the hammer head is made from metal, and The handle is made from wood. Let's assume that the length of the head or of the metal part is 0.2 meters. However, the wood part is 0.2. By substitution, you will just substitute. Let us assume this is our weight 1, 0.5 kilograms times its length, 0.2 plus weight 2, 1 kilogram times 0.2 for its distance, divided by the sum of 1 kilogram plus 1.5 plus 0.5 is 1.5 kilograms. Therefore, you have 0.1 kilograms that meter plus 0.2 kilograms that meter divided by 1.5, and you will get 0.2 meters. Okay? However, the center at which, or however, the center of mass, it refers to the point at which all the mass of an object or system may be considered to be concentrated. So, oftenly used interchangeably with the center of gravity. The center of gravity and center of mass are physically different. So the term center of mass is often used interchangeably with the center of gravity, but they are physically different concepts. They happen to coincide in the uniform gravitational field. But where gravity, or if gravity is not uniform, the center of gravity refers to the mean location of the gravitational force acting on a body. So madalas pinagpapalit si center of mass and center of gravity. Pero not all the time parehas si center of mass and center of gravity. Nagiging parehas lang sila kapag yung kanilang gravitational field is uniform. Okay? So let us have here the examples. If you will notice, the center of gravity, ang sabi po doon, lahat ng regularly shaped object, the center of gravity are found at the centers. Same true with the center of mass. To those regularly shaped object, the center of mass are found at the center of those figures. Okay? So for instance, sweet moments of the two persons here playing as a seesaw. Let us assume that the girl here is 45 kilograms and her distance from the fulcrum is 8 meters. However, the boy here is 75 kilograms and his distance from the fulcrum is 4 meters. And therefore, they are balanced at the seesaw. Now, if you are asked to determine its center of mass, same expression with the center of gravity, mass of the first object times its displacement plus the mass of the second object times its displacement plus the sum of the mass of the first and second object. By substitution, you will get 45 kilograms times 8 meters, referring to the mass and the distance of the girl, plus 75 kilograms times 4 meters, referring to the mass and distance of the boy from the fulcrum, all over the sum of its masses, and therefore you will have 360 kilograms that meters plus 300 kilograms that meters is all over 120 kilograms, and therefore you have 660 kilograms that meter all over 120, canceled out yung kilograms, therefore you have 5.5 meters. So the position of the boy is at 5.5 meters to balance the girl. Okay? Now, In the case of the location of center of gravity of human body, the center of gravity of human bodies vary. Based on the illustration on the picture, when a person is standing, the center of gravity is within the torso. But when a person bends his body, example, pushing a cart or reaching the toe, the center of gravity moves out of the body. Okay? So much for that. Hopefully, nakatulong po ito sa inyo. Itong aking simpleng video lesson ay nakatulong po sa inyo. At kung bago ka sa channel ni Sir Fox at ito po ay nagustuhan mo, huwag mong kalimutang mag-subscribe at i-hit ang notification bell all para maging updated ka sa mga susunod ko pong video lessons. Happy learning, everyone!